So another important concept is knowing when and how insoluble compounds are affected by pH. And really, what that requires is knowledge of which acids are strong and which are weak. And so, um, like in Chem 1A, we said, oh, there's, I think, 5 strong acids: HCl, HBr, HI, HNO3, HClO4. I think that was it. Those were the lists. But in fact, there's a lot of strong acids. And really, we base on pKa's. And so here's what you'll be doing when you look at compounds. You'll basically be ignoring what's on the left. Like I just picked all the silver compounds, okay? And when you look at the rest of it, you notice these are all anions, and all of them can be the conjugate bases of weak acids. So, for example, HBRO3, HBr, H2CO3. These are the acids that would form if you changed the pH and made the solution more acidic. So what we have in all of these situations, okay, we have a situation of coupled chemical reactions. And I don't think your book actually talks about it like this, so you may have to go back and look at the stuff that I talked about earlier if you skip that. But you have HBr, you have, let's do AgBr, simple one to look at, because it's just 2 ions, right? Solid. And then equilibrium, right, with silver ion. This is what we're doing in this chapter, plus Br minus. Now, Br minus is also part of a weak, an acid. I'm not going to say it's weak or strong yet, but it's HBr, right, plus H2O makes H3O plus Br minus, like that. Okay, so now, here's the thing. If you affect the concentration of bromide, you affect the molar solubility. If you can make it go down, then the molar solubility goes up. If you can make it go up, then the molar solubility goes down. Because if you make this go up, it shifts to the left, right? And if you make it go down, it'll shift to the right. And molar solubility is based on how much you can dissolve. So, anything that manipulates the bromide ion concentration potentially can affect the molar solubility of silver bromide. Now here's the thing, HBr is a strong acid. So that means the reaction only goes one way, and that adding hydronium to the solution, let's say you add it in the form of nitric acid, right? Well, adding hydronium to the solution won't have an effect because you don't affect the bromide ion concentration and form HBr. Now, had bromide been fluoride instead, right, then what would have happened is it would have been pH dependent, because the hydrogen ion, right, would bind to the fluoride ion and form HF, which is a weak acid. So it really boils down to, right, is the anion the conjugate base of a strong or a weak acid? Some of that you'll know like intuitively, like Br is one of those ones that you memorize. Cl is one of those ones that you memorize. So I'm going to put an X next to the things that aren't affected by pH. So silver bromide, right? Silver chloride, silver iodide for sure, right? And then that's it that perhaps you know about. The other ones are strong acids that you might not know about. And I know you're wondering, well, how will I know, right? Well, this is how you'll know. So strong acids aren't listed in this table, okay? So let's go ahead and look up what would be bromic acid. I got to switch back here, hang on. Bromic acid, HBrO3. So again, you'd have to know the name of it, but there's not a bromic acid listed here. That's probably the only way you'll know, I think. I can't think of another way you'd know. And it is, in fact, a strong acid. It's actually one of the stronger acids. I looked up its pKa because I didn't even know the pKa. Um, I think it's 10 to the minus 30. Hang on, let me double check that. Yeah, it's 10 to the minus 30. It's not even listed like in most common tables. So that's a strong acid. So this one's not affected. Oh, sorry. This one's not affected by pH. But I only knew that by looking in the back. I didn't find it in the table, so I have to assume that it's a strong acid. Now, carbonate you'll find. Carbonic acid's a weak acid, so that one will be affected by pH. Okay. Let's see. Chromic acid. So let's go back to our table and look up chromic acid. You'll notice there's no chromic acid here. So we're going to make the assumption that it might be a strong acid. I'm going to tell you that's wrong here in a second, but you might make the assumption that's a strong acid. I don't know how you would know otherwise other than looking it up, okay? But it turns out chromic acid is H2CrO4 is similar to sulfuric acid in that in its first ionization, it's strong, and in its second one, it's weak. Okay, so I'll get to that when I talk about sulfate. I just forgot chromate was in that list. So, oh, sorry, the first ionization would be plus water and make H3O plus HCrO3 minus. So that one's strong, but the second ionization is weak, and so that one you would expect to have some dependence on solubility. And I'll get to that, some of that on the next slide. So this one will be pH dependent. This one will be pH dependent. This one will be pH dependent because phosphoric acid is a weak acid. Sulfuric acid is strong, but this is what I was getting at. The first ionization is strong and not the second. And then H2S, it's called hydrosulfuric acid, is a weak acid, and so this one would be pH dependent. So let's look a little bit at like how they're pH dependent. Okay, so let's start with one of the. Let's start with the. Let's see. Let's start with silver cyanide. It's an easy one to do first. AgCN, solid, right? And then it makes silver ions plus cyanide ions like this, okay? And then HCN is a weak acid. So you could think of it as HCN plus H2O makes H3O plus CN minus. And this is the common ion part, okay? So if I increase the hydronium, go to high H plus concentration, that means low pH, okay? Then what will happen is this is going up. So this shifts to the left. Actually, let me use a different color for this. Oops, didn't mean to do that. Oh gosh, trying to see the icons shift on me there. I don't know if you can see that. It's like playing a game with me. So if you go to low pH or high hydronium, and you can do this not by adding HCN, you do it by adding like nitric acid, something that strong acid that just produces hydronium. Then what happens is the hydronium ion concentration goes up, and then this equilibrium shifts. So that what happens is the CN concentration goes down. Now these are coupled. This is where they're coupled at, right? This is the point. So that means this is going down, so it'll shift to the right. Sorry, shift to the right. And this means, right, S is increasing. So more silver ion will be dissolved in solution when the pH is low or the hydronium ion concentration is high. And that's why I wrote this at low pH, right, high hydronium, solubility is always higher for these kinds of weak acid conjugate base things, okay? Now, you could go the other way too, right, but You can't, if there's no cyanide in the solution, right, like no HCN in the solution, making the pH lower, you can't actually make more cyanide. Typically speaking, right, insoluble compounds, if they're coupled to a conjugate base of a weak acid, those will be more soluble at lower pH. Okay. Now let's look at a more complicated one. I'll do the sulfuric acid because that's one you may encounter more commonly. But H2SO4 is a weak acid. So I have H2SO4, sorry, is a strong acid. The second ionization is weak. So I get H2O, all right, makes H3O plus S HSO4 minus. And then I have the second ionization. That makes H3O plus SO4 2 minus. Now, going back up to our table here, silver, right? Sulfate is also insoluble. So I can say AgSO4, Ag2SO4 is in equilibrium with its ions, 2 Ag plus ions, plus SO4 2 minus. So this first ionization is strong. And the result is right, this right, is equal to the concentration of the sulfuric acid. But it turns out this one's not. The second ionization is weak. Now, it's not that weak. It's, of the weak acids, it's one of the stronger ones. But it's still going to be pH dependent, okay? Now, when you look at the solubilities, right, it's not this ion that we're concerned about. It's actually this ion. And so sometimes people get confused in these polyprotic ions because this one's not affected. Because even though it comes in from sulfuric acid, this one's not affecting our solubility. So this one is. And you really have to look at the form of the ions so that matches what's in the equation. These are what are in common, not this. Okay. So since the sulfate concentration is coupled to this hydronium concentration, and HSO4 minus is weak, right? Then again, the solubility of silver sulfate will be somewhat more soluble as you go to lower pH or higher hydronium ion concentrations.